If sensitive data reaches your vector store, your security problem started upstream. Presidio lets you catch and redact it before the chunker ever sees it. This is the pattern you'll be able to implement by the end, which removes personal details before splitting text and stores only sanitized chunks for search. I'm Professor PI, teaching AI engineering and LLM systems with simple Python. Most retrieval augmented generation pipelines start with raw documents. They then split those documents into chunks and save embeddings in a vector store. The risk is obvious. If a document contains names, phone numbers, or account identifiers, those secrets end up in the index. That creates a long tail of exposure when models or users query the store. The goal here is simple. Detect personal data early. Remove or replace it. Then chunk and index only the sanitized text. Think of it like a pre-filter at the door. You want to stop secrets before they mingle with thousands of chunks. Presidio is a focused tool for this job. It has detectors tuned for names, emails, phone numbers, and it can be extended with your own patterns. Using it before chunking keeps your embeddings and search safe, and it often reduces audit surface without destroying context. In concrete terms, we will take help desk messages, detect PII, replace it with neutral tokens so the meaning stays intact, break the safe text into chunks, and run a simple similarity check to pick the top chunk for a query. You keep retrieval utility while removing secrets. Strengths are direct control and clear audit trails. Weaknesses are the usual trade-offs. More aggressive redaction loses signals, and brittle custom patterns can miss rare formats. We will build a tiny, readable path that you can apply to your own corpus. You will see detection, replacement, chunking, and a retrieval example. No heavy indexing required. Now we'll initialize Presidio and detect PII in a toy message. This snippet initializes Presidio and detects PII in a short help desk message. We first import the Presidio Analyzer engine and Anonymizer engine to prepare detection and future redaction. A compact message with a phone number and email goes into the variable text. The Analyzer object runs Analyze with language set to English, producing a list of findings that includes offsets and entity types. We derive the unique entity types into the list types to see which detectors fired. Finally, we print both the categories and total findings, so you can confirm coverage on this minimal example. The printed result shows which secrets Presidio can catch at ingestion time, proving the detector is active before any chunking or indexing. Next, we'll swap detected items for neutral tokens so the text can be stored safely. This example replaces detected PII using Presidio Anonymizer engine to yield a safe text preview. We import operator config and build the ops dictionary to map each entity type to a replace action with clear tokens. The Anonymizer uses both the original text and the prior analyze results, so it only transforms actual findings. The returned object contains the redacted string in its text field, which we store in safe text for downstream use. Replacing rather than fully redacting preserves context for retrieval while ensuring secrets are gone. If you switch replace to redact, privacy increases, but retrieval signals may drop. The print confirms the message is safe to persist or index. Now we'll chop the sanitized text into bite-sized pieces and score them against a toy question. This code chunks the anonymized text and ranks chunks by query similarity. The function chunks splits the safe text into fixed-size word windows, so indexing can operate on smaller units. The function Jaccard computes the overlap between query and chunk vocabularies, returning a score between 0 and 1. We create a small candidate set, CS. Define a simple query queue, and select the best scoring chunk with a max over scores. The final print shows the numeric match and the chosen chunk content that would be stored or embedded. Increasing the chunk size may improve context, but can dilute scores and increase index payload. Smaller chunks trade some context for tighter recall and latency. Next, we'll extend detection with a custom pattern for internal account identifiers. This snippet adds a Presidio PatternRecognizer to catch custom account identifiers and ensures they are anonymized. We define a pattern with a clear ACCT 12345 style regex and wrap it in a recognizer that emits the account ID entity. By calling analyzer.registry.addRecognizer, we extend Presidio's detection without changing other logic. We analyze a new message containing an account ID, then extend the ops dictionary to replace account ID with a neutral token. The Anonymizer produces Safe2, which contains no original account ID. Tuning the regex or the confidence score reduces false positives, but may miss edge cases when set too strict. The printed count and preview confirm our new secret type is now protected. Finally, we'll run a tiny end-to-end loop over 2 documents and retrieve a top chunk. This example builds a tiny end-to-end path, Presidio anonymization, chunking, and retrieval of a top chunk. We gather 2 source messages into docs and loop through them, calling analyzer.analyze and anonymizer.anonymize to create safe docs with secrets removed. We form an in-memory index of chunk triples by applying the earlier chunks function at a consistent size. A simple query Q2 is compared against every chunk using the Jaccard function, and the highest storing candidate is selected. The final print shows a similarity score and the returned redacted text, demonstrating that retrieval operates only on safe content. Smaller chunks raise index size and latency. Larger chunks improve context, but can blur match specificity. Mapping this toy example to production is straightforward. Replace the in-memory index with your vector store or embedding pipeline. Run Presidio during ingestion. Persist the safe text, and store embeddings from the sanitized chunks. Add logging of findings for audits, and treat the anonymized versions as the canonical persisted documents. Recap. What it is: a pre-chunking PII filter using Presidio to detect and replace sensitive tokens. When to use it: when you must keep indexes free of secrets while preserving retrieval utility. One caveat: overly aggressive or brittle patterns can remove useful signal or miss edge formats. Next step: tune the chunk size for your corpus so you balance context and index size and measure retrieval quality versus latency. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.